All right, we're going to work through problems using the ideal gas law under changing conditions. We can recognize this because something's changing. There's two values of the same variable in the statement of the question. In this problem, we see that there is two different values of temperatures. If there's two values for the same variable, we have changing conditions. We're going to use this rather cumbersome looking equation here. It really isn't that hard to generate. We start simply with the ideal gas law, and then we say that this ideal gas law corresponds to condition 1. Then we do the same thing, and we say the gas law corresponds to condition 2. Then we show one equation divided by the other equation. And finally, R is a gas constant, so it simply cancels out. So this is the equation that we're going to use. Now this is the equation we're going to use when it comes to dealing with ideal gas law under changing conditions. All right, and this is how it works. We're going to define two different conditions. Clearly, these two measurements go together, and we're searching for the other measurement associated with that condition. Now we're going to call this condition 1 and this condition 2. We could have gone the other way. It doesn't matter. We would have gotten the same answer. We could have called this condition 2 and this condition 1. As long as we're consistent, we're going to still get the correct answer, i.e., what we want are these two values together. All right, so what are we asked to calculate? We're asked to calculate a pressure that's going to exist under condition 2. So in this problem, we're going to solve for P2. We want to make things easy on ourselves by canceling out those things that remain the same, unless there's specified values for the other variables. We assume that they are going to remain the same. For example, nothing is said in the problem about numbers of moles. Therefore, we know the number of moles is not changing. N1 is equal to N2, and that allows us to cancel this out. Additionally, V1 must equal V2 because there's nothing said about volume changing. So these two variables cancel each other out. Now all I did was rewrite this equation so it didn't look so messy. Now again, the question asked what pressure exists at this temperature. So this is going to be P2, and we're going to solve our equation here for P2. The easiest way to do this is to cross multiply. Okay, now please, people lose points all the time trying to skip steps. Go through these steps. So we're going to multiply P2 times T1, and that's going to be equal to P1 times T2. And again, what we've done here, P2 times T1 is going to be equal to P1 times T2. And remember, we've decided we're going to solve for P2. And now we substitute in our values. Remember, temperatures have to be in Kelvin. So we're going to convert this to Kelvin. So we have 273 plus 27. That's going to be equal to 300 Kelvin. And for this temperature, we have 273 plus 337. Okay, now T2 is going to be equal to 610 K. So T2, we substitute in 610 K. T1 is 300 K. All right, if we look at our units, we see K cancels with K. And remember, we're solving for pressure, P2. We see our final unit is in atmospheres, which is good, which is what we want. So we get our answer. Finally, we can ask ourselves if our answer makes sense. So we take a sample of gas and we heat it to a higher temperature and the pressure increases. That makes sense.